Welcome. My name's Lynn Olson. I'm a Principal Consultant with Snowden and Product Manager for our Supervisor Advanced Geostat software package. Today I'm going to give you an overview demonstration to show you some of the functionality in our Supervisor version 8 product. When we load data into Supervisor, we can load from a CSV or text file or directly from some of the major software packages. For this demonstration, I'm going to load a CSV file. This is a nickel laterite data set. It has multiple domains and multiple assays. Now there's three main parts to the Supervisor screen. On the left, this will be a tree look of what data we've loaded and what domains we're looking at. The center is where we'll see our information, and on the right hand side is our properties where we can change things. The software will automatically map domains and assays that it knows. So here I'm mapping my assays. I can tick on and off the ones I want to load, and I've got a domain field called domain. I can load that and it will provide me a summary table of what data I've loaded and will give me some automatic graphs. If I expand out the tree on the left, you can see the graphs I've got automatically. So I've loaded this initially with assay at the top level and domain underneath it. So I'm seeing nickel with 8 different domains. It's very flexible. We could do that the other order if we like. I could change my grouping to domain over assay and regroup it, and I now get domain 11 with each assay under it. So you can look at it in any order that you'd like to. If we have a look at the main graphs, automatically you get a histogram, a log probability plot, and a mean and variance plot. Everything is interactive, so I can move these statistics around. I can rescale my graphs by just clicking and dragging. And in the properties, I can adjust things such as changing from a normal scale to a log scale. Some of the great flexibility about Supervisor is in its ability to group things. So things will be grouped automatically by what we call grandparent, which means 2 levels up. But we can change that. I can group something by the whole project. What that will mean is it gives me the ability to select, in this instance, every histogram in the project. If I use my Shift key, I can see all of them at once. Now, I've got a lot of histograms, so that's going to be a lot of graphs. I'll change that back to being grouped by grandparent, and I'll just get the histograms for nickel. So I've got 9 histograms, a global one, plus 1 for each domain. Once I have them grouped, I can change things on them all at once. So it makes it very quick and easy to carry out analysis and to change parameters. The log probability plot is also a default. We're very flexible in terms of what you can and can't see on the graph, so we can turn those statistics on or off. We can change the scale from log to normal. We can turn it from a probability plot into a CDF just with a click of a button, and by using that grouping you can do everything at once. Now, one of the great features about Supervisor is that if I've decided I've got some new data, I don't have to carry out my analysis again. I can come back, I can select a new data set and reload it, and it will refresh everything that I've got in this tree. So I can set all my variograms up, all my graphs up that I want, and then I can just refresh every time I get new information. Now, some of the graphs that we have in here, we can do box and whisker plots, comparing the statistics of each domain. You can see here that domains, this is domain 11 and domain 21, they're quite similar. We could come in and do a QQ plot between domain 11 and 21 and review that further. If we decided that they should really be combined, we can come into the top of the domain level and we can adjust the domaining. This is a simple filter operation, so instead of saying domain equals 11, I can say domain is in 11 or 21, and that's now the combined data. Another really flexible thing is the copy and paste functionality. I can come to my domain level and use Control-C and then Control V to paste it back in, and I've got a second version of that. This one I could turn back into just domain 11. So you could set your variograms up, for example, and then you could take a copy of it and you could apply a filter to just maybe look at the southern or northern extents, and you can update it and very quickly see the change. We can also do scatter plots and look at correlations very quickly. If we come down and have a look at domain 11, I can add a correlation matrix. What this will do is work out the correlation coefficient between all of my grid of assays. I can click on those to see the different scatter plots. Using your shift keys and your control keys, a bit like Windows, normal Windows functionality. When it comes to variography, it's all very interactive. So if we add in here a horizontal continuity fan, it uses fans which graph the variogram values. We can change the parameters, the transforms on that, and very quickly create a horizontal continuity fan. Now I'm working here with a data set of almost 6,000 points, so it's quite a lot of information. And it probably takes about 2 minutes to run that with 6,000 points, so it's very quick for large data sets. So this is my continuity fan. So if it is red, it means it is above the sill. There's my scale, my grade scale here. Everything is standardized, so 1 means it's at the sill. The yellow bar down here is a lag adjustment, so I can very quickly adjust my lag and see the difference, and I can zoom in and out on the scale bar. I can also look at all the variograms that are sitting in behind those fans at the same time. So here's all my variograms. I can use this to pick which direction has the longest continuity. So I can do this by looking at them all together. I can also overlay them. There's an overlay mode option which will overlay any graphs that you've selected. Or I can click into one of these and then I can use my up and down arrows on my scroll bar to scroll between them. And you can see on the left that the blue line is moving around as I move my variograms. Now once I'm happy that I know my direction of continuity, of longest continuity, I can point my arrow in that direction. And then I can go and look perpendicular to that to see whether there is any dip on the mineralization. There's shortcuts which make things a lot quicker, so I can simply click on this shortcut and I get what we call an across strike fan. So we're now looking perpendicular to our strike direction. Now this is nickel laterite. So nickel laterite is very flat lying, and you can see here in the fans it's quite obviously flat lying deposit. If you need to, you can also look at the variograms as well as the fan. Once I've got that second direction, if I'm working in something that is three-dimensional, that isn't perfectly flat, I can also add a third fan, which is what we call the dip plane. This looks in the plane of the mineralization to see whether there is a plunge on the mineralization. On this final fan, I can pick which direction I want to be my major direction for my variograms, and then I can insert some variograms using this next little shortcut key, and it's automatically going to calculate variograms for me. Now, because this nickel laterite doesn't have any plunge, it is flat lying, I get a choice. Up and down here is my dip and left and right is my strike, so I'm going to point my arrow towards my strike direction so that that becomes my major direction. Now when I add my models, I automatically get a downhole and my 3 directions. I automatically get rotation angles specific to the software package I'm using, and if I'm using normal scores variograms, I automatically get a back transform. Now I can look at these variograms individually, or I can look at them all together. There's an auto-fit process, so it's automatically fitted a model with 2 spherical structures in a nugget, and everything's linked. So we can come to our downhole and we get quite a good model off the auto fit. We can adjust our lags using the lag drag bars, and you'll see if I move one of these, all of them move, so I can interactively fit very quickly my variograms. All the scaling is interactive. And you can see if I decide this one needs to go up, the other one moves up as well. So it makes it very easy to fit your variograms. Once you've modeled them, you can look back at the Models tab and see three-dimensionally what they look like. So I now have a variogram model calculated extremely quickly for a domain. I could then take that and copy it using my Control-C and paste it into another domain. I can update that and I can see whether I'm getting the same patterns in a different domain. So this is now domain 25. You can see it probably is slightly different. It's got a lot less data, but you could use that as a starting point. We automatically get a back transform model as well if we've used a normal scores. Now the other thing that's very useful is the 3D viewer when you're doing variography. If I click into this 3D viewer, I can see the plane of that variogram. So this is my variogram fan, my horizontal, and this is the direction I've picked. Now it's interactive, so if I click up onto domain 25, I'll see domain 25. I can then look at my dip, and I can see the pink arrow plus the blue arrow. So the pink one's the one I pick as my final direction. When I come down to my continuity models, I can now see an ellipse of what my grade continuity looks like based on my variogram. Now some of the other features that we have in here include our latest addition, which is a Kriege neighborhood analysis tool. Now the Kriege neighborhood analysis tool is added underneath your variogram, and what it does is it looks at statistically optimizing your estimation parameters. It calculates Kriege efficiency and slope of regression for a test area, and it graphs the results for you. I'll give you a demonstration of this. If I go into it and add a KNA, a Kriege neighborhood analysis, I can set up block sizes that I want to test on the right-hand side. My parameters are automatically grabbed from my variogram, so my search is taken from the variogram, although we can adjust that if we want to. Now you can manually select a location for the test, or I can go into the 3D viewer and I can actually see here where my blocks that I'm testing are, and I can move those interactively. So I can change the location and pick exactly the location that I want to be testing. I can do the same in the vertical. I've changed the location, so I can come back here and update this. And now I get two graphs for this. I get the first graph, which is Kriege efficiency in red and slope of regression in blue for each scenario I've tested. And I also see the negative weights. Now the negative weights gives me the sum of the weights going down in red and the number of weights going up in blue. So you can see I'm getting negative weights in this particular situation. If we pick the scenario that we like the best, so the best result here looks to be 20 by 20 by 10, we can select that and we'll automatically get another scenario, which is now looking at the number of samples. So I can look at, say, 2 to 100 samples at steps of 1. What happens if I only use 2 samples for the estimate? What happens if I only use 3? And again, it's going to graph the results for us for the particular block size we tested. Now we can select multiple block sizes and you'll just get multiple sample graphs underneath it. So here's a graph for our number of samples. Now we can use this to pick what we think is a good minimum number of samples and maximum number of samples. So how much data do we need to get a decent estimate, and how much do we want to use? Again, we get the negative weights as well, and you can see here you start getting negative weights kicking in quite early in this particular scenario. There's two other options in the K&A. One is to look at the search. It bases this on the variogram range and ratios 2 smaller and 2 higher. And it uses the number of samples that we set up in our previous one. So in this instance, there's not much difference in them. And the last one it does is looks at discretization. Again, you can set up the discretization grids that you want to test and update it. I can show a summary of those results. So this is the scenario I've picked and the estimation parameters I've picked. Again, I can copy and paste that and very quickly test other scenarios. So I could look at a what-if scenario. What if my variogram is a lot worse? What if I look at this for a different test area? So I can take a copy of it, paste it back in, and move the test area. The last of the major features I wanted to show you is declustering. So we also have a decluster function. Unlike most software packages, this will actually automatically graph the results of the declustering for you. So it calculates declustered mean grades using a variety of different cell sizes, so it's cell-weighted declustering. We can then graph the results and pick the scenario which we think is removing the clustering. So you can see here our naive means 2.77 and we're getting mean grades down to around 2.69, 2.7. If we select the cell size that we think is removing the clustering bias, that is then applied to our statistics, and my statistics here are now decluster weighted. Now that is the major features that we have in Supervisor at the moment. The next tool that we're looking at adding towards the end of the year and then additional features next year is a model validation toolkit. That will allow you to load your estimate once you've run it and validate your estimate against your drill hole data. The first feature will be a trend plot or swatch plot, which will graph the input data against the estimate by domain, and it will again be interactive. So there will be a drag bar similar to the lag bar to allow you to change the slice size on those trend plots. There will also be additions of statistical comparisons between the data and the estimate, and then next year we'll be looking at adding a global change support function to that. Thank you very much for listening to my demo. Hope to see you at the next one.